has confirmed it's launched an attack on Iran.
At 7:10 in the morning, somewhere in the dark waters of the Middle East, a single command is transmitted across a secure American naval network. Seconds later, a hatch opens on the deck of a destroyer. A flash of fire erupts into the sky. One cruise missile climbs upward, then tilts toward the horizon. 90 seconds later, 8 more follow. Within minutes, dozens of Tomahawk missiles are racing across the night at nearly 900 kilometers per hour, hugging the terrain, invisible to most radar systems. Their destination? Some of the most heavily guarded military facilities in Iran. For decades, military analysts have debated a question that has never truly been answered. What would happen if the United States and its allies launched a coordinated strike against Iran's military infrastructure? How fast would events unfold? How would Iran respond? And how close could such a confrontation bring the world to a much larger conflict? The scenario you are about to see explores one possible answer. In modern warfare, the opening minutes often decide everything. Before fighter jets cross borders or bombs fall on targets, the battle begins in the invisible domain of sensors, satellites, and electronic warfare. Long before the first explosion, powerful jamming systems may already be blinding radar networks. Cyber units could be disrupting communications. Reconnaissance drones might be circling silently thousands of meters above the ground, mapping every movement. Imagine an operation designed to strike dozens of targets within a single hour. Command centers, missile launch sites, air defense systems, drone bases, and naval facilities. Each target selected not just to destroy equipment, but to disrupt coordination. In modern military planning, the objective is rarely simple destruction. The real goal is paralysis. Now picture the skies filling with aircraft. Stealth fighters moving ahead of the main strike package, scanning hundreds of kilometers of airspace with advanced radar. Electronic warfare planes flooding enemy frequencies with interference. Strike aircraft carrying precision-guided bombs capable of hitting a window-sized target from kilometers away. Meanwhile, hundreds of kilometers below them, mobile missile launchers hide in mountain valleys. Underground bunkers protect command networks built over decades. Radar operators stare at glowing screens, searching for threats that may already be above them. History shows that even the most advanced defenses can be overwhelmed by speed, coordination, and surprise. During past conflicts, the first wave of attacks often targeted air defenses and communication networks, creating corridors in the sky for follow-up strikes. Once those corridors open, events can escalate with incredible speed. But war plans rarely survive contact with reality. A single radar detection, an unexpected fighter interception, or a missile launched from a hidden platform could change the entire operation in seconds. What begins as a precision strike could spiral into a massive regional conflict involving multiple countries, naval fleets, and thousands of aircraft. In this video, we will walk through a dramatic hypothetical scenario of how such an operation might unfold. The missiles, the aircraft, the targets, the defenses, and the chain reaction that could follow. Because in modern warfare, the most dangerous moment is not the explosion. It is the moment just before it happens, when the world still has no idea what is already on the way. At exactly 7:10 local time, the calm of the early morning is broken by a sudden burst of fire from the deck of the American destroyer USS Spruance. A vertical launch cell opens, and a Tomahawk cruise missile erupts upward in a column of flame before sharply tilting toward the horizon. Within seconds, it disappears into the pale light of dawn, flying low over the water. It is the first shot of a coordinated strike designed to hit multiple military targets across Iran within a narrow window of time. 90 seconds later, more launch cells open across the destroyer's deck. 8 additional Tomahawks roar into the sky one after another, their engines igniting as they begin the long flight toward the Iranian coast. But the Spruance is not acting alone. Hundreds of kilometers away, another wave of missiles launches from submarines hidden beneath the Arabian Sea, while additional destroyers in the strike group fire their own salvos. In less than 3 minutes, over 30 cruise missiles are already in the air, racing toward their programmed targets. The Tomahawk is one of the most well-known cruise missiles ever developed. Introduced in the 1980s and used in conflicts from the Gulf War to operations in Syria, the missile is designed for long-range precision strikes. Modern variants can travel more than 1,500 kilometers and fly at low altitude, often just 30 to 50 meters above the ground, making them difficult for radar systems to detect. Using a combination of GPS guidance, terrain contour mapping, and onboard navigation systems, the missile constantly compares the landscape below with digital maps stored in its memory. In this scenario, each missile carries a conventional high-explosive warhead designed to destroy infrastructure such as radar stations, air defense batteries, command centers, and hardened storage facilities. Their routes are carefully planned hours before launch. Some missiles approach targets from the coastline, while others fly deep around mountain ranges to strike from unexpected directions. Military planners call this tactic multi-axis penetration, a method intended to overwhelm defensive systems that are optimized to watch only certain directions. As the missiles cross the Persian Gulf, their onboard computers begin a series of programmed altitude adjustments. Several drop even lower, skimming just above the surface of the water to avoid detection by long-range radar systems along the Iranian coastline. Others climb briefly to communicate encrypted status signals with surveillance satellites before descending again into terrain following flight. Inside Iran's coastal radar stations, operators monitor large radar screens that sweep the skies every few seconds. The systems are designed to detect high-altitude aircraft or ballistic missiles, but low-flying cruise missiles present a different challenge. Mountains, buildings, and natural ground clutter can hide them until they are already dangerously close. In the first minutes of the operation, the incoming missiles are still too far away to trigger most detection systems. At the same time, several American electronic warfare drones move into position along the edge of Iranian airspace. These aircraft broadcast powerful interference signals across multiple radar frequencies. Officially, their purpose is to create confusion in the air defense network, forcing operators to question what they are seeing on their screens. In reality, the electronic noise is only one part of the strategy. According to several military analysts, similar operations in the past have used decoy drones that intentionally imitate the radar signature of larger aircraft, causing defensive units to misidentify the true threat. Roughly 12 minutes after the first missile launch, the Tomahawks begin crossing the Iranian coastline. Flying at speeds close to 880 kilometers per hour, they split into multiple groups as their navigation systems guide them towards separate objectives. One cluster heads toward a naval installation along the Gulf, another toward a radar complex believed to coordinate regional air defenses. A third group continues deeper inland, following valleys between mountain ridges to stay below the radar horizon. From the perspective of the crews aboard the destroyers and submarines that launch them, the missiles are already gone. The launch tubes are sealed again, the decks quiet, and the ships maintain their patrol formations. Yet hundreds of kilometers away, the real phase of the operation is just beginning. Within minutes, the first impacts are expected, and the opening strikes will determine whether the rest of the mission unfolds according to plan or spirals into something far larger. Minutes after the first Tomahawk missiles cross the Iranian coastline, the strike enters its second and far more visible phase. High above western Iraq, 12 F-15I fighter jets begin accelerating toward the Iranian border. The aircraft belong to a long-range strike package prepared specifically for deep penetration missions. Known as the F-15I Ram, these fighters are a specialized variant of the American F-15E Strike Eagle, heavily modified with Israeli avionics, electronic warfare systems, and extended fuel capacity. Built for long-distance attack missions, the aircraft can carry a heavy payload of precision weapons while still maintaining high speed. The formation has been flying for more than an hour in near radio silence. Their routes were planned down to the second. Tanker aircraft refueled them earlier over the desert, allowing the fighters to continue toward their targets without stopping. The pilots now approach the final phase of their mission, a high-speed strike aimed at several key facilities in Tehran. As they cross into Iranian airspace, their onboard systems immediately begin scanning the environment. The F-15I carries advanced radar capable of tracking both aerial and ground targets from long distances. At the same time, electronic warfare equipment monitors radio emissions across a wide spectrum, searching for signals from radar installations or surface-to-air missile systems. Every piece of data is automatically shared across the strike group through encrypted data links, giving each pilot a constantly updated picture of the battle space. The targets selected for this phase of the operation are not random. Military planners often focus on locations that represent command authority or operational coordination. In this scenario, one of the most sensitive targets lies within a heavily protected district of Tehran, where several administrative and security buildings linked to Iran's leadership are located. Intelligence analysts believe the complex houses communication nodes used to coordinate certain branches of the country's security apparatus. Roughly 200 kilometers from the city, the strike group climbs slightly in altitude. This maneuver allows their weapons to achieve maximum range. Each aircraft carries Rampage standoff missiles, a precision strike weapon designed to attack fortified targets from outside the reach of many air defense systems. Unlike older, unguided munitions, these missiles rely on a combination of GPS guidance and inertial navigation to maintain accuracy even in environments where electronic interference is present. At the designated release point, the formation begins firing. One by one, the missiles separate from the aircraft and ignite their rocket motors. Within seconds, they accelerate beyond the speed of sound, streaking eastward across the sky. From the perspective of observers on the ground, the missiles would appear as faint flashes high above the clouds, moving too fast to track with the naked eye. Meanwhile, a second wave of aircraft is already approaching the area. Several stealth fighters, designed with radar-evading shapes and special coatings, move quietly toward the outskirts of the city. These aircraft are equipped to carry small-diameter bombs, such as the GBU-39, precision-guided munitions capable of striking specific structures while limiting the size of the blast area. In modern warfare, such weapons are often used when planners want to target particular buildings or infrastructure nodes, rather than create widespread destruction. Inside Tehran, air defense operators begin receiving scattered reports of unusual radar activity. Some systems briefly detect fast-moving objects approaching from the west, but the signals appear only for seconds before disappearing again. Part of the confusion is caused by terrain and atmospheric conditions, which can distort radar returns. Another factor is electronic interference in the region, generated by multiple airborne platforms operating along the edges of Iranian airspace. As the first missiles descend toward their targets, their guidance systems switch into terminal navigation mode. Small control fins adjust their trajectory dozens of times per second, ensuring the weapons remain on course despite crosswinds and changing air pressure. Military engineers often describe this phase as the most critical moment of the entire flight. A missile that has traveled hundreds of kilometers must now strike a specific structure with precision measured in meters. Moments later, the quiet morning over parts of Tehran is shattered by the first impacts. Explosions echo through several districts as the missiles reach their programmed coordinates almost simultaneously. Within seconds, smoke rises above multiple buildings, and emergency communications begin flooding local networks. For the strike aircraft already turning west towards safer airspace, the attack has lasted only a few minutes. Yet the effects on the ground will trigger a chain of reactions across the entire region, signaling that the conflict has entered a new and far more dangerous phase. As the first waves of missiles and long-range strike aircraft complete their attacks, the operation shifts into a far more complex stage. Earlier strikes have already forced parts of Iran's air defense network into a reactive posture. And this brief window is exactly what coalition planners were waiting for. The next targets are critical military facilities that coordinate defense operations across the country. Among the most significant of these is the Iranian Ministry of Defense complex, a large administrative and command structure, responsible for overseeing procurement, logistics, and strategic planning within the armed forces. High above the region, a small group of stealth aircraft begins its approach. These fighters are designed specifically for missions where avoiding detection is essential. With carefully shaped airframes, internal weapons bays, and radar-absorbing materials, they are built to reduce the radar signature that traditional air defense systems rely on to track incoming threats. As they move toward their targets, onboard sensors continuously gather information from the environment. Modern stealth fighters do more than simply avoid radar. They act as airborne intelligence nodes, collecting electronic signals and transmitting targeting data to other aircraft, operating dozens or even hundreds of kilometers away. As the aircraft close in on Tehran, the pilots prepare to deploy precision munitions designed for high accuracy and controlled impact. Among these weapons are GBU-39 small-diameter bombs, compact guided bombs developed specifically to strike fortified structures while minimizing collateral damage. Despite their relatively small size compared to traditional bombs, they carry powerful penetrating warheads, capable of breaking through reinforced roofs and concrete layers before detonating. Using satellite guidance and onboard navigation systems, the bombs can hit targets within just a few meters of their intended coordinates. At the release point, the aircraft briefly open their internal weapon bays. Several bombs drop away silently before their guidance fins deploy, allowing them to glide toward their targets at high speed. Because these munitions are designed for standoff delivery, the aircraft themselves remain well outside the immediate defensive perimeter of the complex. Within less than a minute, the bombs reach the ministry compound. Moments later, several controlled explosions occur almost simultaneously, striking administrative sections believed to house communications infrastructure and planning offices. Military analysts often describe such strikes as attempts to disrupt what they call the administrative nervous system of a defense establishment, locations where orders, information, and coordination flow between units. While these events unfold inland, another part of the operation is already targeting Iran's naval infrastructure along the Persian Gulf. The Islamic Revolutionary Guard Corps Navy maintains a network of coastal bases designed to support fast attack craft, patrol vessels, and mine-laying boats. These bases play a major role in Iran's strategy for controlling narrow maritime choke points, such as the Strait of Hormuz. Over the past 2 decades, the IRGC Navy has developed tactics focused on swarming attacks using large numbers of small, fast boats armed with rockets and anti-ship missiles. One such installation lies near the industrial port region of Asaluye. Satellite imagery over the years has shown hardened shelters built into coastal terrain where fast attack boats can be hidden from surveillance and protected from airstrikes. In the current scenario, planners consider this base a priority target because of its potential role in disrupting international shipping routes in the event of a wider conflict. Several cruise missiles launched earlier in the operation are programmed to strike key points around the facility. As they approach the coastline, the missiles divide into separate trajectories, each targeting a different structure within the complex. Radar arrays, communication towers, and maintenance areas are among the designated coordinates. Within seconds, multiple detonations ripple across the base as the missiles impact nearly simultaneously. But the strike does not end there. Shortly afterward, a strike aircraft equipped with heavier penetrating munitions approaches the area at medium altitude. Its target is one of the reinforced boat shelters built to protect missile-armed craft from aerial surveillance and attack. The aircraft releases a GBU-31 Joint Direct Attack munition, a 2,000-pound precision-guided bomb widely used by modern air forces. Equipped with satellite guidance and inertial navigation, the bomb adjusts its trajectory as it falls, steering directly toward the entrance of the hardened structure. When it impacts, the warhead penetrates deep into the reinforced concrete before detonating, sending a powerful shockwave through the interior of the shelter. Farther east along the coast, attention shifts to the strategic port of Chabahar. Unlike many other Iranian ports, Chabahar sits near the Gulf of Oman and provides access to open sea routes beyond the narrow confines of the Persian Gulf. The port has both commercial and military importance, and its infrastructure includes docking facilities capable of supporting naval logistics operations. Operating hundreds of kilometers offshore, the aircraft carrier USS Abraham Lincoln coordinates the next phase of the strike. Carrier air wings are designed to project air power rapidly across large distances, and in this scenario, several F-15E Super Hornet strike fighters launch from the carrier's flight deck. After forming up over the Arabian Sea, the jets head toward the Iranian coastline, carrying precision bombs and anti-infrastructure munitions. As they approach Chabahar, surveillance aircraft relay updated targeting data regarding several installations believed to support naval command operations and fuel storage. When the strike fighters reach their designated attack corridor, they begin their bombing runs in rapid succession. Precision-guided bombs strike storage tanks, communication buildings, and docking infrastructure used for military logistics. The impacts send thick columns of smoke rising above the port area as secondary explosions erupt from damaged fuel reserves. One of the final strikes targets a reinforced pier complex believed to support specialized naval operations. The attacking aircraft releases another heavy guided bomb aimed at a subsurface docking structure partially built into the harbor. Such facilities are sometimes used to prepare naval mines or support small submarines. The bomb strikes the reinforced concrete structure with enormous force, collapsing sections of the pier and sending debris into the surrounding water. Throughout these attacks, electronic warfare aircraft operating outside Iranian airspace continue broadcasting interference signals designed to complicate radar tracking and missile guidance. Their purpose is not only to protect the strike aircraft, but also to delay coordinated defensive responses. By disrupting communication links and radar coverage, these systems create uncertainty within the air defense network during the most critical moments of the operation. By the time the final strike aircraft begin turning back toward international airspace, several major military facilities across Iran's southern coastline and administrative centers have been hit within the span of less than an hour. Yet despite the scale of the operation, coalition planners understand that the most dangerous phase may still lie ahead. Iran retains significant missile forces, air defenses, and regional allies capable of responding in unpredictable ways. The opening blows of the conflict have landed, but whether they will end the confrontation quickly or ignite a much larger escalation remains an unanswered question. By the time the earlier waves of strikes begin to fade from radar screens, the operation enters its final and most strategically important phase.